The last thing that we need to learn here is what a molecular formula is, the difference between an empirical and molecular formula, and how to calculate a molecular formula if you are given the molar mass. A molecular formula is the exact formula of the molecules present in a substance. Remember that only ionic compounds are simplified to the lowest whole number ratio, because molecular compounds actually form molecules that can be multiples of the simplest formula. The molecular formula is always an integer multiple, that is a whole number multiple, of the empirical formula. How do you know when you need to calculate a molecular formula? Well, the problem must give you the actual molar mass of the compound. What do you do to calculate the molecular formula? Divide the given molar mass by the mass of the empirical formula. Then multiply each subscript by this value. If we look at the example of glucose, if we are just given the masses, we can calculate the empirical formula. We can calculate the empirical formula from the percent composition. However we do it, we end up with the simplest whole number ratio is CH2O. But yet, we are given in all of this that the molar mass of the substance is actually 180 grams per mole. If we figure out the molar mass of CH2O, a carbon, 12, 2 hydrogens, about 2, and oxygen, 16, we come up with 30. So we take the given mass, 180, the problem gives us that. We divide it by the empirical mass, 30, and we get 6. So what that tells us is that we have to multiply each subscript by 6 to get the actual molecular formula. So if our empirical formula is CH2O, we multiply the 1C by 6, and we get C6. We multiply the 2 hydrogens by 6, and we get 12. We multiply the 1 oxygen by 6, and we get 6. Remember the problem we did in the last tutorial, the empirical formula for P2O5? It was tricky at that time because it involved a fraction. Well, there's more to that problem. We know that the molar mass of that compound is actually 283.88 grams per mole. Let's figure out the empirical mass. 2 phosphorus, 5 oxygen, and we get 141.94 grams per mole. Divide, and that is the empirical mass, divide the given mass by the empirical mass, 283.88 by 141.94, we get 2. That tells us that we have to multiply the subscripts by 2. So P2O5 becomes P4H10. This is actually how this compound exists in nature, as a molecule that is 4 phosphorus, H10 hydrogen bonded together. Molecular compounds only have molecular formulas. Ionic compounds are always reduced to the simplest form. If we have an empirical formula of CH, but we are given a molar mass of 78.11 grams per mole, how do we figure out what the molecular formula is? Well, we figure out the mass of CH, a carbon and a hydrogen, 13.02 grams per mole. We take the given molar mass, we divide it by the empirical molar mass, and we get 6. Therefore, this molecule actually exists as C6H6. Multiply each subscript by 6. Now here's a problem that brings everything together that we have done. We get the percent composition of adipic acid. That's fun to say, isn't it? Adipic acid. And we get the molar mass as 146 grams per mole. We have to figure out both the empirical formula and the molecular formula. Now the answers are there, but we're going to work through this because this problem has everything in it that you need to know. First, calculate the empirical formula. Remembering that percent equals grams out of a 100 gram sample. Figure out the number of moles of carbon. Figure out the number of moles of hydrogen. Remember, you're doing this by dividing by the molar masses found on the periodic table. Figure out the moles of oxygen. Divide by the smallest to get a whole number ratio. Well, the only whole number you have out of that is the 1. The other numbers we can see are the decimal equivalents of 1/2. 1.5, 2.5. So what are we going to do? We are going to multiply each of these values by 2 to get rid of those fractions. If we multiply one of them by 2, we have to multiply all of them by 2. So these are the actual ratios of the empirical formula. We're getting rid of the fractions by multiplying all of them by the denominator. C3H5O2. There's your empirical formula. But we're not done because we were given a molar mass. 146 grams per mole. The mass of the empirical formula, 3 carbons, 5 hydrogens, 2 oxygens, is 73.08 grams per mole. There's the empirical molar mass. (146) divided by the empirical mass gives you 1.998. That's awfully close to 2, so we're going to round it to 2. We're going to multiply each subscript by 2. There's our empirical formula. Times 2, C6H10O4. There's your molecular formula. That's everything you have to do in these problems. Thank you. Come to class tomorrow ready to work on a real challenging set of problems to see if you understand this material.